Hello and welcome back to another ACT Math video covering intermediate concepts seen typically in the middle of the ACT Math test or throughout the entire test, sometimes early, sometimes middle, sometimes late. In this particular video, we're going to be covering functions. As always, if you find the video helpful, leave a like, comment with what you like to see more of, what you like that you've seen so far, or anything that you're finding confusing, and subscribe if you want to help out the channel, help others find the channel, or see when I post more videos. But let's get right into it with functions. They are going to be written something like this, with a letter on the outside of some parentheses and a letter on the inside. And these are just two examples. It can have all sorts of combinations, but I'll go into what all that means here using this example. F of x equals x plus 3. Now you might have noticed I just said f of x instead of f parentheses x. That is how you read out loud a function. It doesn't really matter. You're going to have a written test anyways, but I'm just pointing this here so that way as I'm reading this out loud to you, you know what I'm talking about. So you take the letter on the outside, and you say of whatever is on the inside of those parentheses. So f of x. So let's break down what all of these components are, because it just looks funky. It's not actually that complicated. It's just a convenient way of writing things when you have several variables and several equations. So the letter on the outside, so this f, that's the actual function. So we would refer to this whole thing as function f. That's what we're actually solving for, is f. The thing inside the parentheses, so this variable, the x in this case, that's the variable that you need to know in order to determine f. So that's why it's written this way, f of x. In other words, is the function f that is dependent on x, the thing on the inside. And then this side of the equation, that's what you plug this variable into to solve for this. So we need to know x so that we can plug it in to x plus 3, and that answer is the value of f. Really complicated in how it looks if you're not used to it, but it's actually very simple. Because in reality, for our purposes, this is really just a fancy way of saying y equals. Because if I had given this to you before, and just said y equals x plus 3 and asked, well, what is y when x equals 2? You would just plug 2 in for x and say y is 5, because 2 plus 3 is 5. That's all this is, but we replaced y equals with f of x equals. Instead of solving for y, we're solving for f. Why would we do this? It's just helpful if there are several equations being used. So y equals is perfectly fine when we have one equation, but what if we have two equations that are totally separate? We could call it y1 and y2, but the more you have, the more complicated that gets to have y1, y2, y3. So instead they just assign a letter to each one. So equation f, equation g, equation h. It's the same thing. So that's the whole reason they do it. So instead of y now, the result is just f, or whatever letter is on the outside of the parentheses. Now I do want to point out that if you see f of x like this, a really common mistake is that people see this and think that just means f times x. Because often, if you have something and then another letter next to it, in parentheses, that means it's that times that. But when we're specifically talking about functions, so it's just a letter and a thing in parentheses equals, it's not this times that. It's this function that is dependent on this, which you plug in to the stuff on the right. So let's use this example here to cover a few more important points. When you are solving these, the question isn't normally going to say x equals 4, or whatever value. Sometimes it will, but there are other ways of writing it. Sometimes it's going to put that value of the variable inside. So again, in this case, the variable inside is x. They're going to put that variable inside the parentheses of the function. So instead of having f of x equals x plus 3, and saying, well, what's the value of that when x equals 4, they might just put f and then in parentheses 4 and ask, what is that? So exactly what I was talking about. If I have f4, that just means what's the value of f when x is 4. So they're just telling you it's dependent on x. We know this from up here. So if x equals 4, we're going to plug 4 in wherever we see an x. So you just take the value inside that parentheses and you plug it into the variable on the right side. So we would take the 4 and plug it in over here for x. So let's actually solve a few now using this same function. So let's start with the f of 4 that I was talking about. So again, this is the same way of saying, what is the function f when x equals 4? Well, all you're going to do is take that 4 and plug it in for the x. So f of 4 equals 4 plus 3, so 7. Now I'll do the same thing for f of 10, which again is another way of saying, what's the function f when x equals 10? So I'll just take the 10 and I'll plug it in for x. So f of 10 equals 10 plus 3, or 13. So that's all there really is to functions in their basic form. Now again, it's not always going to be f. This could be any other variable. F and g are the most common that you're going to see in an ACT though. So now let's talk about what happens when there are multiple functions. Because that's the whole point of this, as I was saying, is really just helpful when you have several of these. The ACT is not always going to give you 2, just because it's testing, or especially earlier on, a more basic idea of functions, but in reality, this is more like what you'd be running into. So here we have 2 different functions, and both of them depend on x. So here we have f of x still being x plus 3, but we have a new function now, g. Still depends on x, but now to solve for g, we have 2x minus 6. So let's start with the equation. What's the value of f15 plus g of 4? So 2 different x values. So we'll start with the f of 15. So again, we're going to go to f here, not g, because it's not, we're just on this part. And we'll plug in 15 for x. So right here where we had the x, I'm going to put 15, so 15 plus 3, that's 18. Now let's go get the g of 4. So we'll go to g, and we'll plug in a 4. So 2 times 4 minus 6, so that's 8 minus 6 is 2. So now I have f of 15 is 18, g of 4 is 2. I can now add the 2. 18 plus 2 is 20. That would be my answer. Now, another thing you might see is, well, what's the value of f of x plus g of x when x equals 4? So whereas here we had 2 different x values, here we're going to have the same x value. We're going to do the exact same thing, but instead of plugging in 2 different numbers, we're just going to plug in the same number. So now what's f of 4? We did this on the earlier slide. We'll plug in 4 for the x. 4 plus 3 is 7. And then g of 4, we just did that right here. So I'll just type it down again. You still get 2. And now that I have f of 4 and g of 4, I can get the f of x plus g of x as 7 plus 2. And that is 9. So that's how you would handle multiple functions. Now let's talk about some more advanced problems that you'll find later on in the ACT. And that's where we're going to nest some functions. And so when I say nest, I mean one function inside of another. And they'll look kind of something like this, which I'll break down here in a second. So these are written as a function with another function within the parentheses. So here I have g of x. That looks like something I've seen before, but that is within the parentheses of function f. Whereas here I have the f of x function inside of the function g. So how do I read these, just so you can understand what I'm saying when I'm just reading it out loud? This would be read as you start from the outside in, f of g of x. Whereas this one would be g of f of x. Again, you don't have to know that for the ACT because it's a written test. But since this is a video, I want you to understand what I'm saying when I say these things. So to do these, you have to work from the inside out, which is just like normal math, where you have parentheses. You do what's in the parentheses first, with like the order of operations. Same deal with functions. So for something like this one, f of g of x, we're going to start inside the parentheses. So the first function inside the parentheses of g of x. So we're going to solve for that g of x first. Then, once we have the value of g of x, that can get plugged into the outside parentheses, or outside function, function f. So f of g of x, you just solve for g of x, then plug that in to f. So let's do some examples. I've got the same f and g as a couple slides ago. So what's the value of f of g of x when x equals 4? So start on the inside. The one inside the parentheses is g of x. So let's solve for g of x when x is 4. So g of x when x is 4 is how you would write that. So I'm going to take that 4 and I'm going to plug it in to g of x. So 2 times 4 minus 6 is 2. So now that I know g of x, I can now plug that into f. So I now need to know what is the value of the function f when g of x equals 2. So now f of 2 is what I need to do. Because it was f of g of x, but I now know g of x was 2. So I just plug 2 in to f. So I go up here to the f, I put 2 in for that x, I get 2 plus 3. The answer is 5. So therefore, the answer to f of g of 4 is 5. And that's really all there is to it. So let's take a look at another example. What about g of f of x when x is 4? So it's the same thing, but in reverse. This time, f is inside of g, so I need to solve for f first. So let's find f of 4, because x is 4, and that's the first one I got to find. So plug in 4 for f. So at that x, I'm going to put 4 in, so 4 plus 3, that's 7. So now that I have the inside one, I can plug that in to g. So I need to know what's g of 7, because the f of 4 was 7. So again, I'll go to g and I'll plug in the 7. 2 times 7 minus 6, that's 8. Therefore, g of f of 4 is 8. So that can be kind of confusing because it looks different than how we're used to seeing things, but just remember, like any other math, do what's inside the parentheses first, and then plug that into the thing outside the parentheses. And that's going to do it for functions. Good luck, and I'll see you on the next one.